All right, we're going to go ahead and go over section 5.2a, logarithmic functions part 1. It's the evaluation of logarithmic functions. So now there's a lot of properties. I was beginning to go over properties with you with respects to that. If you had some form of evaluation system of the same base with, let's just do m and n this time because I did n m before. But if these are the same, right, then you can go ahead and write it as m is equal to n. Well, that was one like rule that I was kind of going over with you. Well, now we can do what's called equivalent valuations for rewriting of exponentials into logarithmic functions because they're inverses of each other. So now, if we go ahead and think of it in terms of this, we have the system in a log or excuse me, an exponential function. And by the way, it can be written as this way as well. It doesn't matter how we write it. But now we go ahead and determine what does the output look like. All right. So we're as written as in another form with the logarithmic function. So the way to look at it is to take and think about it as the base of the exponential becomes the base of the log with the word log, and you put that over with the x, or excuse me, the y. I mean, I'm pointing at the y and I say x, but I'm looking at the x, my peripheral caught the x. But the thing is, we can rewrite it as then with the x equals a log of b to the y. So these are the same exact things, except the reason why I do like this way is because you go from here to here, you drop the x down as like I think about it as an elevator. You drop the x down and you bring the b over and you put it as the base of the log and you slide over the y and it becomes this value. Now, and in terms of remembering being that they're inverses, we would just switch the x and the y. Kind of like that's why they're inverse of each other. So, but now if we're looking at an equation such as this one that we're looking at here, we're asked to go ahead and rewrite the exponential equation in the equivalent logarithmic form. So we're looking at a value system of this being the base of the log. So we're going to go ahead, or base of the exponential, and we're going to move it over and sweep it underneath the log because it's now becoming the log, the base of the log. And then we drop the 2 down, so it's -2 equals, and then we go ahead and say log base 2 of 1/4. And if we remember, oh, I didn't teach you this yet, but then I'm going to get into this concept of now the log of a base that has a matching value that we're taking the log base of, it will equal the value of the x or the exponential function. So we're going to go ahead and say that this is the case. Now, with that property, it follows in true with what I was doing over here with you, is that if we can get these to match, then it can be equal. Well, we know that 4 is equivalent to 2 to the negative first, or negative second, excuse me. So we can rewrite this as log 2 of 2 raised to the negative second power. Because remember, we know that we have to make it where it's just these are the same, just like we do the same as this to get them. We did it in the last lecture. We want these to be the same. So then this now is equal to the -2, and we can see that we do have equivalent value systems. So it's equal. Now that's the answer we're looking for, okay, is that we're taking the log base 2 of 1/4 equals -2. Now how you write it, okay, it doesn't make a difference. You're going to get it right if you write it this way or that way, which is on the screen. All right. So unless they tell you how they want you to write it, they say write the log first, then that's what we're looking for. All right. Now, right here it says write the following exponential function as equivalent logarithmic function, okay, or form. So again, it's following that structure that we had before. Now that it's remember about this and how this kind of worked out in our favor to solve these. Well, we can do the same thing in respects to logs too. We can get logs to work in our favor. So what we're going to do is, again, sweep that, drop the 2, sweep that log, or that 11, the base of the exponential, as the base of the log, and then we get this. And then remember now that 121 is 11 to the second power, and they're equivalent to each other. So that's kind of cool, and it makes it match up to this concept. That's why I kind of teach this one in the first lesson, and then immediately teach you this one, because they're almost matching up with each other now. They're agreeing with each other. I really appreciate properties when they are agreeing with each other, because it's less to remember. It's just it's a different form. All right, now it says write the following exponential function. Again, this doesn't matter what we're given. We have this. All right, now we look at, well, this is 1. All right, this is understood to be 1. All right, so we can write it as 1 equals log base b of b, and that's actually a property. All right, now this is a property that we're looking for. Remember this property, that it's the same thing as this, but we get this property that log base b of anything raised to the first power is equal to 1. So in the case of that, if I had, let's say, example, this, all right, if I asked you what log base 5 of 5 is equal to, it equals 1. Okay, so it doesn't matter what the base or that number is. It could be 15, it could be 25, it could be 10, it could be 132 for crying out loud. All right, so then we get into this concept. So it doesn't matter if there's fractions or not. I mean, we're looking at now taking the base, the -5, set it equal. I'm going to make the log come first. I've been making it where the log comes second, but we can do log base 5 of them 1 over 3, or 3125, and then we have this -5. So again, 3,125 is equivalent, when it's in the fraction, of 5 to the -5th power, and it does equal, and it follows this form right here. All right, so we're looking at answers. I should be providing them to you, but I'm giving them to you. They're all the same. Okay, except for mine, of course, are backwards, and they will accept it, being that it's, if you put the, I'll just prove it right now. You put 2 and then equals, and then we're putting a log, right? We gotta have that log. So now the thing is that when it comes down to it, they don't have it. So you just type in log and then put in your valuation of this, and 11, and then open parenthesis 121. All right, and then there's our answer. Okay, 1 of 1. So it doesn't matter how you write it. You can write it as the 2 and then the log, and then this log and then the 2. So I'm just proving that it doesn't make a difference. All right, now I'm going to let you have some of these. I mean, you know, I do need to teach you a little bit about whenever there's an E involved. Okay, E is the ln, and that's for natural log, by the way. I don't know why ln, but it's n. You can look at it as nl, reading it backwards, but it's natural log. That's not an I. That's not the word in. It's ln. So just so you know, it could look like a capital I, but it's not. Okay, this is log. This is ln. Okay, next to each other. All right, now for this, of course, we have this. I just want to go over in the use of, whenever you see this, okay, we can go ahead and put this as our answer, by the way. We can drop the y and make it become log base e of 8. Now, whenever you have log base e, that's the same equivalence of writing, and this is, by the way, another property, ln of 8, because when you are looking at log, all right, here's two properties. Log is understood to be log base 10. The base is understood to be 10. But when you put in ln, all right, ln, it's understood to be log base e. All right, that is a couple properties you want to know. Okay, so looking at this answer, we have ln 8 equals y. Okay, just like I have here. All right, but that's something you needed to be aware of, and I needed to teach it to you. Now they're getting you into these properties, by the way, because look at the one I just put down here is what they're trying to drive home here, is that when you're looking at the value of log base 10 of 1 equals x. All right, I apologize. No, excuse me. It's I just rewrote it wrong. All right, so the 10 becomes the base of the log, and then you put it right next to the x. Here you have this. Okay. Now, when we get into this, right, it's understood to be this. And then when we have that, okay, and we say it's 1, then it's not so much as it's a property, but it's the way that we write it. Okay, so this follows in to using or going from here to the log, and that's what they're showing you here, is that you just put log x equals 1. You don't put it with the 10. So it's following that property. So they review this with you purposefully inside of your questions to make sure you're being taught that concept. All right, and you can read it and learn about it throughout your lesson. Of course, the textbook has it. All right, now we get into radicals. All right, so radicals we're looking at is a third root of 64 equals 4. Now, the way to rewrite that, right, is 64 raised to the 1/3 power. And now we have the base of the log with the exponential. So what we're going to do is rewrite this to be log base 64 of 4 equals 1/3. Okay. Now, if you to take and to operate your calculator with respects to logs, it's under math, and then you got to go up, 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 up until you find where it says log base, and it's under A. Okay. And then you see log base, it will allow you to evaluate, okay, where it allows you to change the value of your base. And then see that is the same thing as 1/3. All right. So good stuff to know how to use your calculator. If you don't have this updated calculator, the TI plus CE, TIA4 plus, you're going to have to learn the change of base formula, which means you take the log of what you're taking the log of divided by the log of the base. Watch this. So I go ahead and take log 4 divided by log of the base. And that'll equal what you have. So that's what's called the change rule. Log base change rule. You're changing it from change base logarithmic function formula, basically. Okay. I hope that you have an updated calculator. That way you don't have to worry about that, but that's part of the lesson. So now write the following logarithmic equation as its exponential form. So they're now going back. So it's now going from here to here. So you're raising it. All right. So you're going from exponential form or logarithmic form to exponential form. So you're going to see where you have the base of the log. All right. I'm going to show you in a second here. All right, so the base of the log, Now what's going to happen is this is going to sweep. Now think of this as an elevator. The -3 is going to come up. The 9 is going to come and sweep under it. So it's going to be 9 raised to the -3rd power equals 1 over 729. And if you were to literally take your calculator and evaluate that, 9 raised to the -3rd power, you'll get this. But watch, you hit math, enter, enter, and it gives you your answer of 1 over 729. So that it works. Okay, so it's equivalent. So that's our answer we're looking for. Okay. And they want you to do the, again, write the following. So I'm going to just I'm going to write through these pretty quickly. It's going to be e raised to the y power equals 4. All right, done. And then this is going to go ahead and make it 10 y equals 3. All right. I mean, I'm ripping through these pretty quick because they are fast. You're going to go ahead and make it become 3. Well, let me do 5 equals, and then it's 3125 raised to the 1/5 power. All right. I personally would just put this one. I wouldn't put the radical form of it, which you understand how that works, right? This is the index, so that becomes the root system of your radical system. So I'm done with this process of doing this. Now I went over a lot of I've done a lot of explanations of properties now with you. All right, so none of this is really changing. Now it wants us to find the exact value of the following logarithmic function. Now I just went over this rule with you, right? I just kind of went over this with you. Well, that's what they're going to want us to do here when you say, well, log of 11, and we're looking at 121, is 11 to the 2nd power. So since these are equal to each other right here, then my answer is 2, and I'm done. All right, and they're wanting you to kind of do this several times moreover. So we got to find out like 7 raised. I'm just going to kind of take a guess of like say let's say 6. That's going to be too big, so I'm just going to go ahead and do 7 raised to the 5th power, and that's too big still. So I'm looking at something a little smaller. So but this isn't much effort on me just putting a bunch of numbers in there. I mean, I'm going through it pretty quick. I'm just checking. And then now I find that it's 7 to the 4th power, right? So now I go ahead and put 4. That's my answer. 7. All right, so 49 we know is the same thing as 7 to the 2nd power, but because it's in the fraction, it's going to give -7. So our answer is -2. I mean, I said -7, but it's -2 because it's a fraction. Okay. And you can continue this process. All right, this is -3. This is -1. All right, this is what value is that? I can't even read that. Is that a 2 or 3? That looks like a 2, but I would do that. It's 1/2 then, if that's the case. Yeah. So it's 1/2. All right, and I mean, this is -1/5. I mean, these move so quick. -2. That's interesting. That's not 2. It's -2. Oh no, it isn't. I apologize. No, it is not. I'm not realizing this is 1/5. Okay, so it is in fact 2. Okay, because you can take and do log 1/5, and then it's 1/5, right? And if you raise it to the 2nd power, 1 to the 2nd power is 1. 2 to the 2nd power, or 5 raised to the 2nd power is 25. So I'm glad I looked at that. I was seeing this in my mind as being 5 for one reason. Okay, so this is 1/2. So you do the same thing for this one. All right, so let me see if there's anything else. Okay, I'll let you guys continue that. And fractions doesn't make a difference. All right, It's, you know, if you get this one I will do. All right, so it says log. All right. Now the thing is, and what's disturbing is the fact that the 81 and the 256 are in the wrong spots. They should be like this. Okay. But if we wanted to, we could simply just put it like that, -1 there, because all that does is reciprocate our fractions. And the reason why I want to do that is because I know 4 to the 4th power is 256 and 3 to the 4th power is 81. So my answer is -4. And I could have done that mentally. I didn't even need to write it down, but I just did it for you guys. All right. And then when we're looking now at 81, right, we need to make, okay, I'm going to do this one for you too. Log 81 of 9, right? We need to make this 81 because we got to get them to match, right? So how can we make 9 become 81? Well, we got to go up in value systems, but we got to think about it in terms of what 9 really is in terms of 81. So if we think about log 81 of the square root of 81, which is the same equivalent value as 9 is, then these would match. And then that means that our exponential power is 1/2, and therefore our answer is 1/2. All right, so that's what we're looking for that one. And I'll do another one of those kinds. Well, this one is not that hard. I mean, it's the same thing as almost this one. It's just 12 times 12, right? So that's 144. So that's negative. That's going to be -1/2 as well. It's not. It's negative because it's a fraction, by the way. All right. So this is 1. This is 1. All right. This is now. Whenever you're taking the log base of anything of 1, always equals this number, 0. It doesn't matter what the base is. If it's 1, it's going to be 0. Because what is anything raised to the 0 power? All right, 500 raised to the 0 power equals 1. And that's what they're driving home here. Okay, is if you think about whatever you're taking the log base of and it equals 1, the answer is always going to be 0. Now this one's going to be 12. I mean, some of these move very quickly. This is 9. This one, now this doesn't look right? But if you think about 0.001, right, then we're going to go ahead and have 10 to the -1st power. So it's going to be log base 10 of 10 to the -3rd, and we get our answer, all right, of -3. And then this one's going to be equal to 1. This one's 0. This one's going to be -3. 3. 1/3. You're probably thinking, how in the world am I going that fast? It's because I know my properties. I mean, I can see it happening. This one now, what I want you to get used to on this, and you got to get used to these, is when you change this, okay, and you change that index, it's going to be 6 raised to the 1, or well, excuse me, it's e raised to the 6/3 power, which is 2. So therefore, our answer is 2 because ln of e, or log, ln of e raised to some power is equal to whatever that is, because these are this equivalent value systems of whatever. So here's a property, make sure you remember, is that ln of e of x equals whatever the value of its x. All right, so the answer is 2. Because 6 divided by 3, by the way, is 2. So that's why there's so many of these problems, by the way. This one's 1. This one's going to be -18. This one's 6. These move so fast. And this one's 5, 6. And that's it. That's the answer. All right. So I moved very, very quickly in this one because it's actually really, really easy. And I've gone over so many detailed explanations on properties, and I want you to retain the properties. Once you get the properties locked and loaded, all right, property, here's a property, there's a property, there's a property. I mean, I'm going over lots of properties with you. That once you start getting them into your head, then it starts to become repetition, and you just use these properties at will. All right, so let's go ahead and look at the next lesson here soon.